So these look like quiz questions. So if you know these, you're going to be all right on the quiz, I would think. Sal has 5 white t-shirts, 4 red t-shirts, and 6 black t-shirts. I like to write the numbers, 5, 4, and 6. In a drawer, what's the probability he pulls out a t-shirt that's not white if he's randomly selecting? So there's 5 white shirts, there's 15 total, which means 10 of them are not white, okay? A t-shirt that is not white. So that's 10 t-shirts that are not white out of 15 t-shirts total. There's a 2/3 chance that that happens. Now he has 5 white t-shirts, 4 red shirts, and 6 black shirts. Same situation at the beginning. What's the probability he pulls out 3 white shirts in a row? Well, same first probability, right? But when we go back for another one, the probability is going to change. These are not independent events because having one shirt out and then going back for another, there's only 9, not white, 3 white t-shirts. Okay, it's good to read questions just for kicks. I was stuck on the not white. Here we're actually getting 3 white shirts in a row. Well, there's only 5 white shirts, right? And after selecting 1 white shirt, there's only 4 white shirts left, but that's out of 14. And then there's 3 white shirts after that, and that's out of 13. So we can start reducing. The 5 and the 3 multiply together to get that 15 right there. If you cancel that 4 with a 2 and take the 2 out of here, you've got a 7 left. And 2, that doesn't reduce anymore. We just have a 7 times 13 happens to be 91, so we have a 2 out of 91 chance of that happening. And I mean, you can do a decimal. It's just a little cleaner, I would think, to put the fraction there. Okay. So then, Sal's sock drawer contains 52 socks. 14 are white with holes, 22 are black with holes, 6 are white without holes, and the rest are black without holes. The rest, never good enough to leave it at that. Okay. 6 and 14 are 20. 20 and 22 are 42. There's 10 that basically are black without holes. So if he reaches into the drawer to grab a black sock, so we know it's a black sock, what's the probability that it does not have holes? So you can see that it's black. Well, how many, the question is how many black socks are there then? There's 22 black socks with holes, and the rest, and 10 more are black without holes. So you have a total of 32 black socks. What's the probability that it does not have holes? Well, there's only 10 black socks without holes. So these are just the black ones. These are the black ones and without holes. Okay? And that's a total of 10. So you reduce that, and we're in business there, I think. 2 goes into both 5 times and 16 times. 2 goes into that 5 and into that 16. And lastly, the softball coach must decide whether to appoint Dennis or Tommy as the starting pitcher in today's game. But he's 90% sure that Dennis will start. If Dennis starts, the team has an 80% chance of winning. If Tommy starts, the team has a 70% chance of winning. So the probability of winning a game, well, this is a tree diagram. Okay, we got Dennis or Tommy. One of those 2 guys is going to start. The chances of Dennis starting is 0.9. The chance of Tommy starting is 0.1 then. So if he starts, we've got 80%. We're going to win, or we're going to win not. It's better than saying lose, right? So you got a 0.8 versus a 0.2, and you got win versus win not. 0.7 versus 0.3. So the chance of us winning, we could win with either Dennis or Tommy. Dennis or Tommy. So the or means we're going to add it together, but to win with Dennis, we'd have Dennis pitch and win. So that's a 0.72 if we multiply. Tommy pitch and win, that's a 0.7. 0.7 times 0.1 is not 0.7. Common mistake, 0.07. Okay, it's a single digit number, but you have to use 2 decimals. You add those together, you get 0.79er. They have a 79% chance of winning, which is pretty good. I'll take that.